Ecosystems by Martin E. Lee. Why do adaptations vary among species? Surviving in the environment. It can be difficult to stay cool in a hot desert. The fennec fox's large ears help it stay cool. Blood rushes to the fennec fox's ears when it gets hot. Body heat then moves from the fox's blood into the air. So large ears are an adaptation that help keep the fennec fox cool. By contrast, the Arctic fox lives in extreme cold. It must stay warm to survive. Small ears are an adaptation that help the Arctic fox. Its small ears reduce heat loss. The table shows other adaptations of the fennec fox and Arctic fox. Bright colors on the mandrel's face help identify him to other mandrels. Structural adaptations. Many different environments exist on Earth. Adaptations help species live in their environment. Adaptations develop over many generations. A species changes as individuals are born with new traits that give them a better chance to survive. Individuals that survive pass these traits to their offspring. This process repeats over long periods of time. Adaptations help living things get energy. They help them to find mates and to reproduce. They protect organisms from dangers in their environments. Adaptations can be related to behaviors, structures, and some body processes. Behaviors and body processes. Behavioral adaptations can be as important as structural adaptations. The male mandrill uses its teeth for more than eating. He shows his large front teeth to warn off other males. Behavioral traits in animals are inherited over generations. Examples of these behaviors include spiders making webs and birds making nests. Body processes are also adaptations that help animals to survive. Some animals hibernate in winter. Their body temperature falls. Their heart rate and breathing slow down. This helps animals live through the cold. How do organisms get energy? Energy flow in ecosystems. Most living things on Earth depend on the sun's energy, either directly or indirectly. The leaves of a berry bush use energy from the sun to make food known as glucose. Plants use the chemical energy in glucose as energy for their life functions. Plants are producers, organisms that can make their own food. Animals cannot use sunlight to make their own food. Animals are consumers, organisms that get energy by eating other organisms. When a bear eats berries, it gets the energy stored in them. The bear uses energy from the sun indirectly. Toadstools cannot make their own food, but they cannot eat other organisms either. When organisms die and fall to the ground, their bodies decay. A decomposer is an organism that gets energy by breaking down the remains of dead organisms. Toadstools are decomposers. Decomposers return the materials from the dead organism's body back into the environment. Decomposers help provide materials that other organisms can use. Without decomposers, nothing would ever decay. Dead organisms would just pile up forever. Food chains. In an ecosystem, some organisms produce food, while others consume food. This is how energy travels in an ecosystem. A food chain shows a path of energy through an ecosystem. The arrows on a food chain always point toward the organism that is getting the energy. Follow the food chain from the microscopic organisms to the common mussel, then to the herring gull. What other food chains can you find? Food webs. Many different food chains exist in an ecosystem. Food chains have producers and consumers. Consumers often eat other consumers. Organisms may be part of several food chains. A food web is made up of several food chains that are interconnected. Look at this food web. How many food chains include the herring gull? Energy pyramid. A food chain shows how energy travels from producers to the top consumer. But a food chain does not show how much energy moves from one organism to another. Not all of the energy that a green plant takes in from the sun moves to other organisms. The plant uses some of the energy for its own life processes. Some energy is lost as heat. This repeats throughout a food chain. A snake uses energy to slide along the ground. A wood mouse uses energy to dig itself a hole. Organisms must use energy to grow, move, and reproduce. So only part of the energy can move to the next level of the food chain. An energy pyramid is a model that shows how energy moves through an ecosystem. The pyramid gets smaller as it nears the top. There is more energy at lower levels. There is less energy towards the top of the pyramid because most of it has been used by organisms for life processes or has been given off as heat. Only energy stored in the tissues of an organism can pass from one level to the next. How do organisms compete for resources? Competition. Competition is the struggle between organisms to survive when resources are limited. Like all organisms, the animals on the African savanna need food, water, and shelter. The animals that survive get these resources. Organisms that have different needs can live together without competing. Zebras eat the tall, coarse grass. After the zebras eat, the wildebeests eat the shorter grass left behind. Competition takes place between organisms that have similar needs. Resources such as food, water, and shelter are limited in an ecosystem. Organisms can survive when their adaptations are best suited to their conditions. Organisms with adaptations not well suited to their conditions will not survive. Some competition takes place between members of the same species. For instance, lack of rainfall can make water scarce. Only some zebras that compete for water will survive. The successful ones will be those who can live on less water. Competition also occurs between different species. Wildebeests and gazelles both eat short, tender grass. If drought kills many grass plants, gazelles and wildebeests must compete for what is left. All organisms, not just animals, compete for resources. Plants compete for water, space to grow, minerals, and sunlight. Some plants even have ways to reduce competition. They release chemicals into the soil that kill other species around them. Predators and prey. Animals have different ways to get food. Some animals eat plants, but these plant-eating animals may be the food for other animals. An animal that feeds on other animals is called a predator. The animal a predator eats is called prey. There must be a balance between the number of predators and prey in an ecosystem. When there are more predators, more prey is eaten. This doesn't leave enough prey for the predators. Some will be unable to find food and will die. Then the numbers of prey will increase because there will be fewer predators. Predators and prey have adaptations that help them survive. Many predators are adapted to hunt and kill. They may be fast, strong, or have strong senses to find prey. Other predators have behaviors that help them catch prey. Pack animals, such as wolves, work as a group to separate and attack individuals from a herd of prey. An alligator floats with only its eyes and nostrils out of the water. When a frog or other animal comes too close, the alligator suddenly grabs it with its strong jaw muscles and sharp teeth. A sea urchin has sharp, hard spikes. Predators that attack it will get jabbed. Not all predators chase their prey. Hundreds of stinging cells are released into any prey that brushes against a tentacle of a jellyfish. Chemicals in the stinging cells paralyze the prey so that it cannot move out of danger. Then the jellyfish can eat the prey. Prey have developed adaptations to avoid predators. Some prey animals release a poison when they get attacked. Some have bright colors to warn away predators. Others act like a more dangerous animal. Some prey use camouflage to make themselves look like something else, such as a plant, a stick, or a rock. Prey animals also use behavioral adaptations to avoid being killed by predators. Have you ever heard the expression, playing possum? It means to hold very still. When threatened, possums play dead. Predators that only hunt live prey will leave them alone. The poison dart frog is brightly colored to warn away predators. Glands in the frog's skin release bad-tasting poisonous chemicals. Symbiosis. Symbiosis is a close long-term relationship between organisms that benefits at least one organism. One type of symbiosis is parasitism. In this case, one organism is helped, but the other is harmed. The parasite is the organism that is helped. The host is the organism that is harmed. Parasites do not usually kill their hosts. This is because they need the host for food. Parasites may live outside of their hosts. Fleas are parasites that live off the blood of mammals. As the flea gets blood, it can make the host itch. In some cases, the host can become ill. Parasites may also live inside a host. Horses may take in parasites called tapeworms when they graze. The tapeworms live and feed in the horse's intestines. This can cause poor digestion and affect the horse's growth. When two organisms live together, both may benefit. Mutualism is a symbiotic relationship in which two organisms benefit from living together. The cleaner shrimp eats bits of dead tissue and parasites from the moray eel's mouth. A relationship that benefits one organism, but neither benefits nor harms the other, is called commensalism. Barnacles that cling to the side of a whale get food from the water, but do not help or harm the whale. Symbiosis in the human body. You are part of many symbiotic relationships. Most are harmless, but some can hurt you. Here are some examples. Mites are very tiny creatures. They can live on your skin or at the base of your eyelashes. They get food by eating dead skin cells. E. coli bacteria live in your intestines. They survive on food you have digested. They make vitamin K, which helps blood to clot. A fungus causes athlete's foot. This fungus lives on the skin of the foot. If you have athlete's foot, the skin on your feet looks dry and cracked. It can itch and feel hot. How do materials cycle through ecosystems? Recycling matter. The amount of matter on Earth is limited, just as energy is. So why doesn't it run out? The reason is that much of Earth's resources keep moving through ecosystems. Organisms need key materials such as nitrogen, water, carbon, and oxygen. If the materials did not move in cycles, they would run out. Earth's cycles allow organisms to use the same materials over and over. Three main cycles of nature are the nitrogen cycle, the carbon cycle, and the water cycle. Nitrogen cycle. All living things need nitrogen. It is a key part of protein, which all cells must have. Air is about 78% nitrogen, but the nitrogen in air is free. It is not mixed with other elements. Organisms need nitrogen that is fixed, or combined with other elements. Bacteria that live in the soil can fix nitrogen. Some bacteria live in nodules, or bumps, on the roots of plants. The bacteria take in food from the plant. The plant gets nitrogen from the bacteria. Animals get nitrogen by eating plants or prey that ate plants. There are other ways for fixed nitrogen to enter the soil. Lightning fixes a small amount of nitrogen. Rain carries this nitrogen into the ground. Decomposers also put fixed nitrogen into the soil as they break down dead organisms. Then plant roots absorb it. How does nitrogen get back into the air? Some bacteria live freely in the soil. These bacteria break down fixed nitrogen into free nitrogen that can enter the air. This steady movement of nitrogen through ecosystems is called the nitrogen cycle. Carbon cycle. About 18% of your body is made up of carbon. Carbon is cycled during photosynthesis and during cellular respiration. It is cycled in other ways too. Decomposers, such as fungi and bacteria, break down waste and dead organisms. Carbon is released during this process. Some organisms do not decompose. Over time they may form fossil fuels, such as coal, oil, and natural gas. These organisms had carbon in them when they lived. It gets released into the air when fuels are burned. Carbon is also released as carbon dioxide when volcanoes erupt. Water cycle. Life depends on water. Just think about a day without a sip of it. Many chemical reactions that keep organisms alive need water to occur. Water reaches all parts of an ecosystem through the water cycle. As the sun heats water on Earth, the water changes from a liquid to a gas. This process is called evaporation. When water evaporates, it forms a gas called water vapor. Water vapor also enters the air when the leaves of plants give off water vapor during transpiration. Your breath contains water. The breath of animals also contain water. Water in the air rises and then cools. Clouds form when water vapor condenses on dust or salt particles in the air. Water returns to Earth as rain, snow, or hail. How do ecosystems change? Natural changes. Mount St. Helens, located in the state of Washington, erupted in 1980. Ash, smoke, rock, and mud covered the area. The land became suddenly bare. Other natural events can also affect ecosystems. Fires, earthquakes, landslides, and floods cause changes. Climate changes affect ecosystems more slowly. Climates can get warmer or cooler. Such changes can affect the types of living things that can exist in that place. Succession is a series of predictable changes that take place over time. Succession happens because living things affect their location. The land near Mount St. Helens didn't stay bare. As organisms die, their decaying bodies help make new soil. After soil forms, seeds may take root and form new plants. In turn, these plants change the environment so that other plants can grow. Over time, animals will come back to the area. Human impacts. Humans are part of the ecosystem where they live. Human activity can change the environment. Some organisms cannot survive these changes. Think of the trash you threw away so far today. In 2001, each American produced about 4 pounds of trash a day. Much of it ends up in landfills. The advantage of using landfills is that they reduce odor. They are safer than open dumps. But they can cause problems too. Unsafe waste, such as paint and batteries, can leak and harm ecosystems. Building landfills can cause some organisms to lose their habitats and die. Over time, landfill space gets used up, and new areas must be found for the waste. People may cause harm without even knowing it. Pollution enters the air when people drive their cars. Power plants cause pollution too. Even ranching and farming can have harmful results. When livestock overgraze, plants die. The soil erodes. Fertilizers can enter the water cycle and pollute lakes and rivers. Saving ecosystems. In 1989, an oil spill damaged the coast of Prince William Sound in Alaska. Millions of gallons of oil leaked from an ocean oil tanker. It polluted the land and water and put a great strain on the ecosystem. Thousands of workers helped to clean up the mess. Many washed oily animals, such as otters, with soap and water. They scrubbed oil from the rocks. But even with all the work and money spent, much of the damage could not be undone. Billions of animals died, including 22 orca whales and 250,000 seabirds. The area still has not fully recovered. Preventing problems. It's better to prevent problems before they happen in the first place. Here are ways you can help. Understand how you affect your ecosystem. Learn how to reduce the harm you cause. Reuse, recycle, or reduce your use of natural resources. Know how ecosystems work. Get involved. Join environmental groups to help. As an adult, you will make decisions that affect yourself and your community. And what your community does will affect other regions in your state and country. These choices may even affect the world at large. Learn to be an informed citizen now. It will make it easier for you to become a responsible adult. Recycling aluminum saves energy. Tires are made from fossil fuels, which cannot be renewed. Ground rubber from old tires can be used as a building material. Recycling plastic items, such as milk jugs, saves natural resources.